Alright, so the following problem wants us to find the current through and the potential difference across each of the four resistors in the circuit shown right here. So what I already did is I went ahead and drew the circuit. So we know the battery is 12 volts and we have four resistors. One's 800, the other's 400, 600, and 560. So the first thing I'm going to do is I'm going to add these two resistors together, and I know they're in parallel. So I'm going to use this following formula right here. So it's going to be 1 over the resulting resistor is going to equal to 1 over 400, which is this one right here, plus 1 over 600, which is the resistor up here. So I went ahead and drew that out, and I figured out that resistor is going to equal 240. So I went ahead and redrew the picture with 12 volts, still the battery, 240, 800, and 560 were given to us. And next thing I notice is I'm going to go ahead and add this resistor with this resistor because they're in the series. So once you add 240 and 560, you know it's going to be 800. So I'm going to go ahead and redraw the battery again one more time, and the whole circuit actually. So there's that, and we know this is still 800 ohms, and we know this resistor is also 800 ohms, and the battery is 12 volts. So we have the following picture now, and we can just simplify this down to one resistor, and we know this is in a parallel circuit, so we're going to use the same equation we used up here, and we're going to do 1 over Req equals 1 over 800 plus 1 over 800, and if we do the math, we'll get one resistor that is just 400 ohms. So we know the current through is gonna, or I'm sorry, the potential difference, or the resulting resistor is just gonna be 400 ohms. So it's gonna be 12 volts again, and we're just gonna draw one resistor that is 400 ohms. So it also wants us to find the potential difference in each one. So we're going to go ahead and use the equation VIR, and we know the battery is 12 volts, and we're trying to find I, and we know the resistor is going to be 400 ohms. So once we do 12 divided by 400, we're going to get 0.03 amps, or 30 milliamps. 30 milliamps. So what we're going to do now is we're going to redraw the circuit backwards, so that way we can find what the potential difference is in each one. So we got 400 ohms by adding 800 and 800 together in a parallel circuit. So we'll draw that one more time. $800 here and 800 there, and we said that this battery gives off 30 milliamps because that's what we found up here. So that means there's going to be 15 milliamps going this way and 15 milliamps going to this resistor as well. 15 milliamps, 15 milliamps. All right, so we're going to redraw it one more time, and we know we found this second one right here by doing a series circuit that included a resistor with 240 ohms and one that had 560 in it. So 240 was up here and 560. So we're going to draw that one more time. And this had 560, like I said. This one was 240. And this one remains at 800 ohms. And we already found that 15 milliamps goes this way. 15 milliamps goes that way, which means another 15 milliamps are going to go this way and this way. And since this is in a series circuit, there's a rule that says that the current remains the same through this resistor as it does through this because it's in a series. So there's going to be 15 milliamps that goes through this resistor, and another 15, the same 15 milliamps are going to go through that resistor as well. Okay? And then finally we got this resistor that came from two resistors that were parallel. One was 600 and the other was 400. So if we redraw it, it looks something like this. And this resistor is 560, remains 560. This top one was 600 ohms. This bottom one was 400 ohms. And this one remains 800 ohms. And the battery obviously remains at 12 volts. So we concluded that this there's going to be 15 amps that goes through milliamps that goes through this resistor, and we concluded that 15 milliamps is going to go through this resistor. So which means coming through this resistor is going to be another combined 15 milliamps. And since this is in a parallel circuit, we know that there's going to be there's going to be a total of 15 milliamps coming through it. And since this top one is 600 ohms and this one's 400 ohms, there's going to be more current going through. There's going to be more current going through the bottom one because there's less resistance. So if we do just a simple ratio, 6/10, which is going to be what's going through this bottom one, 6/10 of 15 milliamps is going to be just 9 milliamps, and that's going to be through this one again. So if we know 9 milliamps is going through this bottom resistor, then there's got to be 6 going through this to make another 14, or I'm sorry, to make 15 milliamps. So 9 plus 6 will give us 15 milliamps. So in conclusion, we found that the total resistor was just 400 ohms, and then in every single one of these resistors we had to find the potential difference, and that was found through this, where we found 15 milliamps going through this one, 6 milliamps going through this, 9 milliamps going through this, and another 15 going through this. So when you add it all together, there's going to be 30 milliamps going back to the battery, which should hold true because that's what we found using our V equals IR equation.